Okay, so now onto the example problems. Remember, for the example problems, you need to copy down all the work that is done to go along with these problems. So make sure that as this problem is worked out, as I work it out here on the screen, that you work out the problem along with me. That way you can get some practice at seeing the steps of the problem and at actually working it through and thinking about the things you need to do as you solve the problem. So again, we're using matrices to solve systems of linear equations. So here's the example problem. For a concert given by the school orchestra, 300 tickets were sold for a total revenue of $1,336. Tickets cost $3 for students and $5 for general admission tickets for the public. How many of each ticket were sold? Alright, so let me slide this down a bit so we can have some room to work. So I'm going to look back at what the problem actually says here and start writing down the information that I know. Okay, so I know that there were 300 tickets total. Okay, so we have 300 tickets. I also know that the revenue, so the total revenue, was $1,336. Okay, so total number of tickets sold, total revenue. All right. Now, it says that tickets were $3 for student tickets. Okay, so $3 per student ticket. And then what I want to do is, didn't really write too well, $3 per student ticket, and then it says $5 for public tickets or general admission tickets. So I'm going to abbreviate that as GAT, for general admission tickets. So what we don't know is how many of each ticket were sold. So what this tells me is that I'm going to have to find how many student tickets were sold and how many general admission tickets were sold. All right. Now as I do this, since these are my unknowns, that means those are going to be my variables. And we could call them anything. What we could do is call it just X and Y. You could choose to call it S and G for student or general admission, but I'm just going to use X and Y. So X is going to be the number of student tickets, and my Y will be the number of general admission tickets. So number of GATs. Okay. So student tickets and general admission tickets. That's what I'm trying to figure out. Now let's look back at the information we're given. There were 300 tickets sold. So I can make an equation just knowing that X and Y represent the number of student and number of general admission tickets and this number 300. Since these are the only two types of tickets that were sold, I know that however many of these were sold and then however many of the Y's were sold, that X plus Y has to equal 300. Okay? So X plus Y, make that clear a little bit, has to equal 300. Now I also know that the student tickets were $3 each, so the profit or the amount of money raised is 3 times the number of tickets sold for students, and $5 for general admission tickets. So that means I'm going to add on $5 for every general admission ticket, or Y, that is sold. And that total, the total amount of money I make, has to equal 1,336. Okay? So this is my system of equations for this problem. These are the two equations we're going to use. But we're using matrices to solve these. So, since we're using matrices, I need to lay this out as a matrix equation. So if you remember from the intro video, we first need to come up with our coefficient matrix. All right, I'm just going to abbreviate that as coef. So that matrix is the coefficients, or the numbers that are in front of my x and y variables. So in this case I have 1x and 1y here. So remember, if there's just an x and a y, there's a sort of an imaginary or a hidden 1 there. All right? So 1x and 1y. And then I have 3x plus 5y. That means I'm going to have 3 as my coefficient for that x, and then 5 as my coefficient here. All right? So here's our coefficient matrix. Then this is multiplied times the variable matrix. Now the variable matrix is made up of my two variables, x and y. And again, notice we put these as a single column. Your variables have to be in a column matrix because we need to have two rows in this one to go with the 2 columns of here, because remember when we go to multiply this is multiplied across, and the second matrix is multiplied down. So 1 times x plus 1 times y. Okay, that has to equal the top number for my answer matrix. So these are my variables, and then these over here are going to be my solutions, or my my answers. So 300 was the answer for the first equation, and the second equation's answer is 1,336. Right. So here's the matrix that we have set up. Now to solve this, I can simply go through my go into my calculator and put this information in, because our goal is to simply get x and y by itself. So my x and y answers, the x and y that work for this particular system, are going to be the answers that I get when I take this matrix, the coefficient matrix, and I take its inverse. So when I do the inverse of this coefficient matrix with 1s on the top and 3 and 5 on the bottom. Okay. Oops. It's lagging a little bit, so you have to bear with me. So the inverse of that matrix, there we go, times the solution matrix. Okay. Remember, we do the inverse of the coefficient matrix times the answer matrix, and that gives us the variables that we were looking for, the x and the y, the missing numbers of tickets. So the inverse matrix, the coefficients times the answer matrix, and this should give me my answer. Now, I'm going to show you how I did this on a calculator. I'm going to pull out of the sketchbook here so you can see what this actually looks like. So what I would do on a calculator is I would go to, after I turn it on, I went ahead and cleared the memory so I wouldn't have anything saved in my matrices, but I would go to second and then hit this little x inverse button. It's hard to read right here, but it says matrix right above the x to the -1 or x inverse button. Okay, so I would go there and it would pull up to this screen, and I would go across. Now normally it's going to highlight where it says names, but I would move it to hit the right arrow until I get over to where it says edit, and I would just edit the first matrix A. Okay, now since matrix A is going to represent my coefficient matrix, if you remember, our coefficient matrix had the variables or the numbers 1s across the top and then 3 and 5 on the bottom. So what I would do is I would set it up to be a 2 by 2 matrix, 2 rows by 2 columns. Remember, the first number represents how many rows, the second represents the number of columns, and I would put in there my the numbers 1s on the top and 3 and 5 on the bottom. Then I would do the same thing. I would go back and hit second matrix one more time, second, and then the x inverse button, and then I would go down to matrix B, and I would make it a 2 by 1. Okay, remember, it was a 2 rows, 1 column matrix with 300 as the first solution and 1,336 as the second solution. All right. Now, after that, I would quit back to my main screen, and then I would hit second matrix one more time, but this time instead of editing it, I'm actually going to use A and B. Now remember, A is the coefficient matrix, so I actually want to use the inverse of this. So what I would do is I would hit enter on matrix A right there, and then I would hit that same button. I go to use matrix, but without hitting the second. If I hit second in the x inverse, it takes me to look at the matrices, but if I don't hit second and I just hit this button, it means that I want to be finding the inverse of matrix A. Okay, and that's what I want. Then I would just simply go back. I would hit second matrix again, and from this screen I would choose number 2, B, because that is the answers. And I would multiply the inverse of matrix A, my coefficients, times the solutions. And if you look, that's exactly what we have right here. Here's the coefficients, the inverse of that, times the solutions, which I've stored in matrix B. And when I do that, that should give me the correct answer. And it does. The answer is 82 and 218. So that means that my x and my y are equal to 82 and 218. And we could check these answers by simply plugging them into the equations we came up with. If you remember, we had 300 total tickets, and if you add 82 plus 218, you get 300. And if I was to plug in 82 times 3, and 218 times 5 and add those together, I do in fact get 1,336. Okay? So it's an easy way to check your answer. Just plug those x's and y's back into the original system you had right here, and you will get the correct answer. So I know that my answer is correct. All right. Now, let me show you how you could do this on your own if you don't have a calculator at home. There is a way you can work with matrices just at home by yourself. Again, I'm not going to go into how you would find the inverse matrix, but I can show you a resource where you can find the inverse matrix and actually multiply this problem out by hand. I'm not going to show you how to find it, but I'll show you a website that will automatically give you the inverse of this matrix, and then you just multiply that new matrix by this little 2x1 matrix right here. So let me show you what I mean by that. So if you go to Google and type in inverse matrix calculator, all right, and then click on this first link, it's going to take you to this weird screen. It says Bluebit Online Matrix Calculator, and all you do in your matrix in this space below, and it has a maximum matrix size of a 32 by 32, so that will be 32 rows and 32 columns. We will never see one of those in this class, so don't worry about seeing anything that big. The way you do this is you simply type in the numbers you want in your first row, so like 1, and then you hit a space, and that lets it know that you're going to the next row, and or excuse me, the next column, and the second value in our first matrix was 1. Okay? So remember, this is the coefficient matrix, and I'm trying to find the inverse of that matrix. So the second row was 3 and 5. So here I have the numbers for my coefficient matrix, and I'm going to scroll down and choose which of these options. Now there are all these matrix functions that we've not talked about. You'll learn more about what some of these terms mean. Some of these terms you may never actually learn, depending on how far you go on your math track. But I want to find the inverse matrix, so I will click right here where it says matrix inverse and click calculate, and it'll pop up with the numbers that make up the inverse of this matrix. So if you notice, the numbers are 2.5, negative 0.5, negative 1.5, and 0.5, and this is the top row and the bottom row. So it's just a 2 by 2 matrix, just like we saw before. So I want to write this matrix down here and show you how this would work. If you don't have a calculator, but you do have internet access, how this would work and how you can do this by hand. So the inverse of this matrix, let me write this down here. So I'm just going to replace where I wrote this matrix to the -1 with the actual inverse matrix. Glad this is finally starting to write a little bit quicker. And I'm going to write this matrix in. So the inverse of that coefficient matrix had 2.5. And just as I said, it's writing quicker, it's starting to slow down. And negative 0.5. And then on the bottom row, it has negative 1.5 and 0.5. And we plug in negative 1.5 and 0.5. Okay? Now, the inverse matrix of 1, 1, and 3, 5 is going to be this matrix. So I don't need to take the inverse. Now I'm just actually multiplying this times the solutions we had from earlier, 300 and 1,336. So if you remember how matrix multiplication works, you multiply across a row and down a column, okay, of the second matrix. So what that means is I need to multiply 2.5 times 300. So my x and y value will equal the first number in the first row times the first number in this first column. There's only one column here. So 2.5 times 300. And to that, we're going to add negative 0.5 times the second number in the column, 1,336. All right. Then we go down to the next row, and that's going to be the second row of my answer matrix. Okay. So I'm going to have negative 1.5 times 300 plus 0.5 times 1,336. So again, all I did was I went across each row and multiplied the first term in each row times the first number in this column, and the second number in each row times the second term in this column. Okay, so across the row, down the column. Now, if I simplify this, 2.5 times 300 plus negative 0.5 times 1336. I'm going to plug that in my calculator. Minus 0.5 times 1336. it gives me the top number actually does simplify to 82, and the bottom number, negative 1.5 times 300 plus 0.5 times 1336 equals 218. So just like that, as long as you have a simple calculator on your phone or something that you could multiply these numbers out and add them up, you will come up with the exact same answer. Okay? So that means since X was the number of student tickets, we need 82 student tickets, and since Y is general admission, we need 218 general admission tickets. Okay? So there's your example. Hopefully that made a little bit more sense now that you're seeing some actual numbers come into use. And then go ahead and you can try the practice problems.